Hello, everyone. I'm Michelle Lipinski, Marketing Manager for the Trimble Autonomy Division. Welcome to our webinar, Powering the Future of Autonomy with Proven Customizable Solutions, presented by my Trimble colleagues in autonomy. We are excited to share Trimble's latest advancements in the autonomy space and how we could partner with you in your autonomy journey. You'll be hearing from our panel of experts from the Autonomy Division, Gary Valeri, Director of Product and Strategy, Damir Gumarov, Product Manager, Ed Norris, Portfolio Manager, and Jackson Chung, Product Engineer.
Thank you, Michelle. Hello, everyone. My name is Giri Baleri, and I want to extend my warm welcome to everyone who's joining this webinar. Let's take a quick look at the agenda. To set the stage, I will take you through the company overview and the evolution of Trimble autonomy technology. Damir will then go over our autonomy product portfolio and technology capabilities. Ed and Damir will then shed some spotlights around newest products and services that Trimble has to offer. Jackson will then take us through the map-based localization and how it helps provide positioning under challenging GNSS environments. I'll then come back to wrap up the presentation by going over some of the real-world customer success stories. So for those of you who are not too familiar with Trimble, we have been around for over 4 decades, dating back to our inception in 1978. Trimble is a publicly traded company on NASDAQ, and we are part of the S&P 500. Trimble's mission is to transform the way the world works by connecting the physical and digital worlds to help solve some of the industry's complex challenges around the world. We have a diverse go-to-market strategy that is tailored to the market segment and to help accelerate the market penetration. So we have customers that are direct end users, dealers, and channel partners, as well as OEMs. Additionally, we also have joint venture partnerships in some key strategic areas. So we serve millions of customers and partners over 100+ countries. Trimble is truly a global organization with our offices around 35 countries around the world, and we are 12,000 people strong. Trimble heavily invests into R&D, which is demonstrated by our R&D spend of over $500 million each year, as well as over 1,000 unique active patents. Next slide, please. Trimble brings scope and scale to its core markets. So you can see here on the screen, there are 4 key core markets that Trimble addresses. Just to put this into perspective, in agriculture, Trimble serves over 150 million acres of farms that farmers are using with Trimble technology. And there are over 345,000 Trimble displays that are used by the farmers in the cab every day. In geospatial, we have over 10,000 surveyors and mapping firms in North America that are Trimble customers. In transportation vertical, over 2 million assets are managed using Trimble technology, and we have enabled over 1 million miles of safe driving using Trimble's functionally safe ADAS solutions. In construction vertical, over 1 million monthly active users use Trimble Connect, which is a collaboration tool that manages about 30 million models and components. Additionally, in construction space, we also have our machine control solutions that are helping improve productivity and efficiency each day. So needless to say that we have decades of deep vertical market experience that we have gathered over the last 4 decades. The autonomy division that we represent provides the horizontal technology and intersects each one of these core markets. Trimble Autonomy is transforming the way the work is done across each one of these industries by making them better, faster, safer, cheaper, and greener. Next slide, please. Trimble's autonomy brand promise is autonomy on your terms. So what that really means is that we meet the customer wherever they are, whenever they need it. So this is a culmination of Trimble's decades of experience in innovation and domain knowledge. Trimble Autonomy Division was established in 2020 to bring intentional focus to higher level autonomy solutions. As you can see, no matter where customers are on their autonomy journey, Trimble has a product and solution to offer. So whether it is providing position and orientation through a portfolio of solutions ranging from entry-level GNSS receivers to all the way high precision INS and integrated GNSS systems, or systems that can be used for real-time ground truthing for development, prototyping, and testing purposes. Or it could be our field-tested, customizable, easy-to-integrate libraries using high-definition mapping and path planning that helps customers optimize their workflows. Or it could be even our localization perception systems that use sensor fusion that's taken from multi-sensor data to operate under heavily GNSS challenged and denied environments. This can also be further extended to provide awareness around obstacles and have strategies to mitigate and work around those obstacles. So wherever you are going on your autonomy journey, we'll partner with you and take you however far you are comfortable going. And that is our brand promise. Next slide, please. Trimble Autonomy technology stack and the positioning stack has evolved over the last 40 years. Trimble started off as a GPS company providing GPS modules. And from there, we used that information to provide precise positioning, and then use that positioning information to improve productivity by creating machine control solutions, and then extended that further into integrated workflows. And currently, we are really connecting all these dots to create this connected autonomy. As you know, this road to autonomy has driven mass scale adoption of high precision positioning and sensor fusion technology in both on-highway and off-road applications. This has been further demonstrated by the modernization of GNSS infrastructure, that over the last 5 years, we have seen many new GNSS constellations that have gone up in the space. There are more modern frequencies that are available today that customers can use. It's also been newer PPP networks that have been deployed around the world. So these enhancements, improvements, as well as the application needs have created a strong demand for higher accuracy, higher availability, as well as higher integrity. And there has also been a growing need for robust solutions in terms of interference mitigation coming from multipath jamming and spoofing and other interference sources. We also see ourselves at an inflection point where the cost and technology capabilities and customer readiness are nicely converging to enable higher level autonomy adoption. Trimble, as a leader in this domain, continues to be at the forefront of latest technological advancements. The Maxwell, which is our core GNSS ASIC, or the center of the chip, is at our 7th generation technology currently at Maxwell 7. ProPoint positioning engine, which is our 5th generation positioning engine, has been designed from ground up with sensor fusion in mind and to deliver the robust positioning and orientation solution. Our global RTX correction service offers fast convergence virtually anywhere in the world. Our map-based localization solution integrates the simultaneous location and mapping along with absolute position to ensure uninterrupted positioning under all environments. Our sensor fusion and perception engine further enables situational awareness and obstacle detection. So we'll talk about many of these advancements throughout the webinar. So this is going to be around the products and portfolio and technology. So I'll let Damir take this on from here.
Thank you, Giri. All right, hi everybody. My name is Damir, and I'm a product manager here at Trimble Autonomy. I would like to introduce the portfolio and the solutions and the technology that allows Trimble to engage higher levels of autonomy and automation. All right, Trimble is able to provide position orientation components for every stage of autonomous development, be that accurate real-time aid and navigation from prototyping to mass production for different levels of precision accuracy, with sensor fusion combined with visual odometry or relative and absolute pose inputs, systems for fleet management, asset positioning required foresight automation, as well as systems for ground truthing, algorithm development, and sensor testing, together with data processing, cloud capabilities in order to achieve higher accuracy, as well as tools for mapping and survey. All of this together is designed to help our customers along their autonomous journey. All right, so here is the boxed product portfolio that's composed of boxed and smart antenna solutions. So if we look at the right side, we have our GT or ground truthing products. These are high-end systems with GNSS and inertial designed for HD mapping, algorithm development, and ground truthing. These systems, together with post-processing software that we provide maximum accuracy in any kind of GNSS environment. The real-time GNSS INS systems listed in the middle are entry-level to mid-grade GNSS and INS systems that have the capability of performing certain activities in GNSS and in difficult environments, and are generally robust and are very accurate for open sky applications. On the left side, we have our real-time GNSS systems, which are just GNSS-only components, both dual and single antenna, that can be incorporated into any customer's basic needs, including use for base station, use for asset positioning, and use for fleet tracking. Next slide, please. Right, here we have the OEM portion of the portfolio, which includes our real-time GNSS INS systems and effectively mirrors our box portfolio. We have the Trimble AP RT200 and 300 on the higher end, higher performance inertial, the BT992 INSCR dual GNSS INS, BT940 single GNSS INS, and as well as just regular GNSS components, BT990 and BT992 single and dual GNSS max GNSS performance systems, as well as the BT9250, our new entry-level product. The above allows for what we refer to as autonomous positioning toolbox. Effectively, this is this altogether assists every step of the way on the autonomous journey for the customer. So the GT systems, for reference, ground truthing and HD map collection and GNSS difficult environments, BX and RT systems for prototyping and mass deployment, and OEM components for deep customer integration. We offer customers integration with visual odometry and map-based localization, which we'll speak more later in the presentation, as well as this allows for sensor fusion in real time, combination of visual data and absolute position. Next slide. Purpose-built to innovate at every step of your autonomy journey, so you can sense, think, and act optimally to meet your strategic objectives. Trimble is using its experience in development of sensors and algorithms for positioning and localization, such as GNSS RTX positioning, INS dead reckoning, SLAM, MBL, visual odometry, and sensor fusion, to create tools and workflows that utilize perception and location data that allows to automate equipment in the field and control actuators, steering, speed, implement with a seamless user interface. All right. At this point, I will hand this over to Ed to introduce some of our latest products.
Thank you, Damir, and welcome everyone. My name is Ed Norris, and in this section, we're going to spotlight some of the new products and services that we have brought to the market for the autonomy industry. The first product I'm going to talk about is our recently introduced BD9250 product. This is a easy to integrate board, GNSS board that has our latest technology on board, but designed for RTK and RTX centimeter level accuracies. Key features of the board are it's a dual frequency board, so it can be configured in the field either as an L1, L2 or an L1, L5 board. That would be dependent on the base station that you may be operating with, that if it only had L1, L2, you would operate in L1, L2 mode, or if you had a more modern receiver, then you would be in L1, L5 mode. As I mentioned, it's an industry standard board. It's in the form factor and connector of the commonly used format, making it easy to integrate into your application using the standoffs. It's powered by our latest generation of ASIC, Maxwell 7, and our latest positioning engine, the ProPoint positioning engine. On board, it integrates a L-band MSS demodulator for access to our RTX services. We also have a version, the BD9250S, which has a support for the Indian NAVIC S-band frequency, which makes it pretty unique in the marketplace there. So the key benefits of the product here mainly focused around accuracy, availability, and integrity. It's a centimeter accurate ProPoint engine, allowing it to operate in obstructed environments. And also we support an onboard spectrum analyzer, as we do in all our products, which allows troubleshooting when you're integrating the product. You can identify interference easily with this. The next product I'm going to talk about is our BX992ER. This is an enhancement of our successful BX992 product, which has been in the market for a number of years. It's a dual antenna GNSS INS receiver, tracking all constellations, all frequencies. Dual antenna allowing you to get instant heading and orientation while static, which is a key benefit of the product. It's designed to be mounted in a vehicle, IP67 rugged enclosure. The ER version, as I'm showing here, has an additional calibration step over a wide temperature range, improving accuracy in all temperature and environments. From an I/O perspective, we support CAN, Ethernet, USB, and RS-232 for easy interfacing. And again, covering the key benefits under accuracy, availability, and integrity. Accuracy-wise, having the dual antenna, we getting accurate heading and orientation, aligning our inertial sensors instantly, and also supporting the onboard spectrum analyzer. So now I'm going to hand it back to Demir for the next product, Spotlight.
I would like to introduce the RT200 and RT300, real-time products with a lot more inertial. Both are dual GNSS INS tightly coupled integration systems, offering a high G range IMUs and chosen specifically for their stability and reliability. Systems provide 200 Hertz positioning and attitude output, as well as CAN, Ethernet, and RS-232 interfacing. These systems are capable of heading alignment while static, and RT300 is capable of heading alignment in GNSS difficult environments. Again, both are designed for robust positioning, accurate orientation, even under poor GNSS conditions. We provide comprehensive ICD for fault detection for both of these units. RT200 comes with an embedded IMU. It is a 40G range unit designed for quick integration and for environments where shock and vibration might not be easily mitigated. Main application is construction, logistics, heavy machinery, and equipment automation. RT300 is capable of orientation without GNSS, and it is a high precision IMU for continuous operation in even the hardest of the GNSS environments. The main application for this one would be large haul trucks and other application where the robust solution will be safety critical in the application. Trimble portfolio also includes a global correction service, RTX. It can be used as a fallback to RTK or as a source of consistent positioning without the need for infrastructure setup. So instead of a traditional RTK correction where base station setup is required, RTX uses satellite propagated signals to transmit the data directly to the GNSS card. As cellular or L-band correction options are available, it provides a global coverage. It is well suited for open field or site-wide applications. Also would like to introduce POSPAC post-processing software used for mobile mapping, ground truthing, specifically HD mapping and algorithm development work, where post-processing software is easy to use, designed for optimal processing of Trimble products, intuitive interface with a variety of processing options to meet every customer need. Takes advantage of the GNSS INS integration and the latest Trimble processing methodologies. It is customizable to meet customer data needs to provide georeferenced output at any location on the vehicle. and it offers a magnitude of user-defined formats to make sure the customer can find the output they need.
Okay, with that, we'll go to the next section of the webinar. I'll hand it over to Jackson to take us through the map-based localization.
Thank you, Gary. My name is Jackson, and I'll be providing you with an overview of map-based localization, or MBL. Next slide. So MBL is our sensor fusion approach where we combine the GNSS, INS, and SLAM solution. We're utilizing LiDAR sensors that are already on autonomous vehicles to generate a point cloud map of the environment where we can track against. This allows our navigation solution to achieve a high accuracy and orientation without drift, especially in GNSS-denied environments. This sensor fusion approach allows for seamless transitions between both outdoor and mapped indoor environments. Next slide. So the MBL solution is independent of the INS solution. As long as the map is available, we can essentially navigate indoors forever without a degradation in the solution accuracy. With in-house software, this will form the basis for which additional autonomy capabilities, such as perception, can be built upon. Next slide. So MBL is a sensor fusion of INS, being IMU and GNSS, and SLAM solution. The advantages of SLAM is that it works best in the feature field environment. For example, urban canyons and inside buildings where there usually is a lot of solid structures to track against. This is usually where INS performance is lacking, as there is poor GNSS reception and or multipath in these areas. And in an indoor directioning situation, due to the accumulation of IMU errors, the solution will start to drift after some time. But with SLAM, once the map is generated, as long as the vehicle is within the mapped area, there is no drift and we can continuously have a high accuracy solution. The disadvantage of SLAM is the opposite. It doesn't work well in a featureless environment, such as open fields or rural areas. But this is where INS excels, as there are usually excellent GNSS coverage in these areas. So with the combination of the two solutions, we can achieve the best of both worlds. Next slide. So this slide shows the MBL user workflow. We begin with data collection in the desired operating area. Then we can generate the map with the data collected. And after the map is generated, any vehicles with MBL will be able to localize within the map.
So with that, let's go to the last section of the webinar. So this is around the applications and the success stories. If you go to the next slide, please. So as I mentioned during the background section of this webinar, introducing Trimble Autonomy, we are a horizontally focused business unit that enables autonomy applications on land, air, and sea. So we have applications that range from a variety of different vertical markets. So for example, in agriculture, our position and orientation technology has been used for machine control solutions such as auto steering, implement control, variable rate technology to help boost the productivity. In mining, we have enabled autonomous haul trucks to ensure safe operations and being able to extract over 1 million tons of ore throughout this process. In the construction, the technology has been successfully deployed to perform blade control and grade control to help improve efficiency and productivity. In rail and train, we have enabled positive train control where customers have successfully integrated Trimble technology and solutions. Similarly, in industrial environments, container ports, distribution yards, etc., where robust and reliable position and orientation data is required to successfully guide manned and unmanned machines, Trimble position and localization solutions have been integrated and successfully deployed. In aviation space, we have several manned and unmanned system integrators that depend on the design integrity and trusted safety of Trimble GNSS and INS solutions. I'm going to talk about the 3 success stories using Trimble technology and how they have been used to solve some of the specific customer problem. The first one would be related to position and orientation solution using our GNSS component. The second one would be using a localization to provide uninterrupted position in all environments. And then I'll wrap it up finally with the complete workflow automation that has been accomplished using the full stack autonomy building blocks. Next slide, please. The first success story I'm going to talk about is the NASQ, whose objective was to build a system that automates file driving by automatically bringing the machine to exactly the right position and then driving the post to exactly the right height. In order to achieve this objective, they needed to get a highly accurate, precise position and orientation technology solutions, and then they chose Trimble's BX992 with AV34 antenna with RTK corrections derived from the base station. This ensured them to achieve this centimeter level accuracy, both from horizontal XY position as well as the vertical Z direction. As you can see, when the operator presses that button, it accurately positions that machine to the next position. And then once it comes to that position, it stops. Then the post gets loaded onto the machine, and then it ramps it down into the ground at the right height. The end result is that one machine can place more than 50 posts per hour just using 2 workers, which traditionally would have taken up to 6 to 8 operators, ranging from people requiring to do surveying, putting the lasers, putting the flags, strings, a lot of guesswork. And this really resulted in a lot of productivity improvements, as well as making sure that they are able to accurately and reliably and repeatably put these posts into the ground. The system also provides real-time data, including the number of posts that are driven into the ground, the pounding time for each post, any refusals or other problems that were encountered, as well as kind of the condition of the machine so that they can be proactive about predictive maintenance. NASQ has used this system in over 300 utility scale solar projects over 5 continents in the last 10 years. So this has been a very successful and very productive endeavor for them. Next slide, please. So the next success story that I'm going to shed spotlight on is IHI, which is Ishikawa-jima Harima Heavy Industries Limited, a Japanese engineering corporation that headquartered in Tokyo. They set out to develop an autonomous workflow of a container and haulage truck at the port harbor in Japan. In order to achieve this objective, they needed to get uninterrupted position as these machines are going seamlessly indoor and outdoor, and they wanted to get position and orientation data throughout the course of their travel. A highly customized RT200 system that Damir showed earlier, in conjunction with map-based localization that Jackson showed us, was used to provide precision and orientation, augmenting GNSS with inertial data. And as you can see, as the machine is going, indoors and outdoors, it's able to seamlessly position itself. And you can see the blue line, that is the reference data, in conjunction with the green line, which is the computed data, and they match fairly well throughout the travel. So by partnering with Trimble, IHI was able to retrofit the system and address 2 major challenges. One was scalability and consistent availability within the autonomous operation in this large-scale industrial environment. Next slide, please. The final success story that I'll present will be the Horsch autonomous sprayer. So Horsch has been a long-term partner with Trimble Agriculture, and it's a company that's based out of Germany, focuses on issues facing the farmers and strives to anticipate farmers' future needs. Trimble and Horsch embarked on a mission to build a future of an autonomous machine and really automate the workflow in agriculture industry related to spraying. The first phase of this collaboration was to improve the machine performance, reduce operating errors for sprayers. So by combining the autonomy technology stack that included precise positioning, steering control, speed control, implement control, perception, path planning, and geofencing, we're able to achieve a fully autonomous sprayer workflow that an operator can pretty much control with a click of a button from a distance using mobile device, such as a tablet. This technology will form the basis for operating fully autonomous machines in the future. So these and many more customer success stories are featured on our autonomy website, and I invite you to read to get more details. So that concludes our webinar for the day. I wanted to again thank all the attendees for participating in the poll, sending us the questions. If you have any further questions, please feel free to reach out to us via that email, info_oemgnss@trimble.com. You can always visit our website, autonomy.trimble.com, to check out our latest and greatest announcements and products and services. Thank you again, and have a great day.